Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Let's have a look at some examples of drawing accurate free body diagrams. So, the first question here is, what are the forces acting on a boat travelling at a constant velocity, and then to categorise them into contact and non-contact forces. So first thing to know are what are the kinds of forces that are going to be acting on that boat. So we have an upwards force of upthrust acting up and a downwards force of weight acting down, but we know that this is moving at a constant velocity. So we also must have a thrust force propelling the boat forwards, and equally matched to that a drag force from the water which opposes the motion of the boat. So those are all my forces, and to categorise them, upthrust, drag and thrust, all contact forces. Weight is a non-contact force because the two objects that are actually interacting with each other there are the boat and the earth, okay, and that force is being propagated by a gravitational field. Okay, the next question is, the boat has a mass of 1500 kilograms and the resistant forces are 4000 newtons. Draw a free body diagram of the boat. So first thing to do here is to know that my mass is not equal to my weight. So if I want to know the size of the weight, I have to figure that out first. And I do it using my equation that we've covered previously. Weight equals mass times g. G on Earth is 10, so that gives me 1500 times 10 is 15,000 newtons. So now I have all of my forces. I need to pick a scale for my diagram. So maybe I'll say that 1 centimetre line is equal to 2,000 newtons. And then I can go ahead and draw my diagram here. So the 4,000 newtons resistive force needs to be equal to the 4,000 newtons thrust, and because that's 4,000 newtons, those two lines should be 2 centimeters long, and then my 15,000 newtons line should be 7.5 centimeters long. Okay, now to draw a possible free body diagram of a parachutist who has a mass of 70 kilograms decelerating. So first thing again, let's figure out what the weight acting down on this parachutist is. So we have their mass multiplied by g, and again g is 10, so that gives us 70 times 10 is 700 newtons. And then we need to think about the fact that if this person is decelerating, then their upwards drag on them needs to be larger than the downwards force due to their weight. So we need to draw some kind of diagram where my arrow upwards, 1000 newtons, is larger than my arrow downwards, 700 newtons. Okay, now we're going to look at some examples of finding a resultant force, and we're going to start when our forces are all acting in a line. So we have got a car with a thrust of 5,000 newtons and a drag of 3,000 newtons with a frictional force of 500 newtons. So first things first, I'm going to sketch a quick free body diagram to show all those forces acting on the car. Okay, and then I need to figure out, I've got 5,000 acting to the right. What is the force acting to the left? So I simply need to add those two forces together. Okay, so 5,000 to the right, 3,500 to the left. Then I'm going to take that 5,000 newtons pulling it to the right and minus the 3,500 newtons trying to pull it to the left, and therefore that will give me my resultant force, which is acting on my car, and that is 1,500 newtons. Okay, let's have a little look at our next question here, which is a plane with a weight of 6,000 newtons and a lift force of 6,000 newtons. The thrust is 10,200 newtons, and the drag is 8,000 newtons. So I've got two different directions here. I've got the up and down of my weight and lift. So let's have a look at that first. And since those two are matching, there's no resultant force up or down for this plane. And then I've got my thrust and my drag. So I draw a quick diagram for that. My thrust off to the right, my drag to the left, and I do the same thing again. 10,200 minus 8,000 is 2,200 newtons. Okay, so now we're going to have a look at what do you do when your forces are not just acting in one line. So here's an example here where I've got an object which has 10 newtons pulling it up and 25 newtons pulling it off to the right. And the first thing I need to do is eventually I'm going to draw a scale diagram, so I need to decide on a scale. So I could say, for example, that 10 newtons is going to be represented by 1 centimetre for my scale. And I'm going to pick one of the forces to draw first. So I'm just going to pick the 10 Newton force, and I'm just going to make sure that when I draw it, that arrow is 1 centimetre long. Then what I'm going to do is I'm going to go to the top of my 10 Newton arrow, and that is where I'm going to draw in my 25 Newton force. So what I do is I then draw that 25 Newton arrow in, making sure it's 2.5 centimetres long to match the scale. And then I finished drawing all of my forces that were involved in this diagram. So the next thing I do is I go to the very start of my diagram, which is the bottom of that 10 Newton force, and I draw a dotted arrow line to the end of my diagram, which is the tip of that 25 Newton force, like that. Then all I have to do simply is measure the length of that dotted line that I've just drawn. That length was 2.7 centimetres, and since my scale is that every centimetre is 10 newtons, that's 27 newtons. Okay, and we're going to have a look at a slightly harder example now. This time I've got 3 different forces, 10 newtons up, 24 to the left, and then at this 45-degree angle I've got this 31.2 Newton force. But the steps that I'm going to take are going to be exactly the same. So if you remember, step 1 is to decide on a scale. And for simplicity, I'm going to keep mine the same here. 1 centimetre is going to represent 10 newtons. Okay, then I need to start drawing in my forces. So I'm first going to draw that 10 Newton force in and make sure that that is 1 centimetre. And then I've chosen to draw that 24 Newton force next and make sure that's 2.4 centimetres long. Okay, then I'm going to now have to draw in my final force here. So I'm going to draw that 31.2 Newton force in. And at the bottom of that force, that's where I draw my dotted line back to the start of my diagram, which was the bottom of that 10 newtons. And that's what's shown in orange here. I can then measure the length of that, and that is 12.2 newtons. And I know that because it was 1.22 centimetres long. Okay, now let's look at some maths examples of Newton's second law. So we have, what is the acceleration of a car that has a thrust force 5,000, frictional force 2,000 and a mass 1,500 kilograms? Okay, so my first step here is just to help me visualize. I'm going to draw a quick diagram including those two different forces. And then I'm going to find the resultant force, which is actually acting on my car. So that's 5,000 minus 2,000 is 3,000 newtons. That's really important because when I use my equation for Newton's second law, F equals ma, that F actually stands for your resultant force. So before you do anything, you need to know what your resultant force is on your object. So that being said, I'm going to use my F equals ma, and I've got my force 3,000 equals the mass was 1,500 kilograms from the question multiplied by A. So to get A by itself, I then divide through the 1500 on both sides, and I get that A is 2 meters per second squared. Okay, and my second question is, what is the thrust of a car decelerating at 2 meters per second squared with a frictional force of 4,500 newtons and a mass of 2,000 kilograms? Okay, so this time I'm looking for something different. I'm actually looking for the thrust force, but in order to figure that out, I need to know, well, what was the overall resultant force that must have been acting on this car? So this is kind of like doing this backwards. So I'm going to find that first. F equals ma, so it's mass 2,000 times 2, its deceleration, 4,000 newtons. So that's my resultant force. So remember, I have this frictional force of 4,500. I have some thrust force that I'm trying to find out, and the resultant of those two forces is 4,000 newtons. So I'm just going to represent that thrust force with a little question mark so far. And since this object is decelerating, I know that my resistive or my frictional force must be larger than my thrust force. So I'm going to say 4,500 minus this thrust force is giving me 4,000 newtons. So rearranging that, my question mark is 500 newtons, and that is the size of my thrust force. Okay, now we're going to answer a few more conceptual explainy questions about Newton's first and second law. So let's have a little look. We have a car travelling at 15 meters per second, and we're asked what is going to happen to the motion of that car if the following things happen. So the first is if there are no resultant forces on that car. And since it is already travelling at 15 meters per second, by Newton's first law, it will stay at 15 meters per second. Remember, in order to travel at a constant velocity, your object doesn't need to have a resultant force acting on it. Okay, next, a larger thrust than frictional force. So now there will be a resultant force acting on my car, and since it's a thrust larger than the friction, that will cause my car to accelerate by Newton's second law. In your exam, I would always state the law that you're referring to in your answer. Okay, and then finally, a larger frictional than thrust. So again, there's a resultant force acting, but this time the resultant force would cause the car to decelerate. Okay, and then next we have a stationary car, and we need to decide what happens to that car with no resultant force acting on it. So in this case, because it was already stationary, it will remain stationary. And what about if it has a larger thrust than frictional force? Well, then it will begin to accelerate away. Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not? Okay, so just some tips and tricks for this section. So firstly, interpreting Newton's first law. So that is the law that states that an object will remain stationary or moving at a constant velocity unless it is acted on by a resultant force. So things to mention here is that if something has zero resultant force on it, it can still be moving. It can still be moving at a constant velocity. That doesn't mean that it's necessarily staying still. It's just not accelerating. Equally, if something is staying still, that doesn't necessarily mean that there are no forces acting on it. All it means is that those forces are balanced. Okay, so that's the most common misconception with Newton's first and second law. Next thing to look out for is if you have a missing force, like a missing weight, perhaps you've been given the mass, and so you can figure out that missing force. And make sure that you have the correct units too. So remember, your mass is in kilograms and your force is in newtons. Finally,
remember to bring a protractor with you, and remember to get used to using a protractor because you may need it for your scale diagrams.